College algebra is a course that is designed to help you get ready for calculus. Now, one of the very first things that you come face to face with in calculus is the difference quotient. So I want to introduce you to the difference quotient here and, and show you some techniques for evaluating the difference quotient. Now, let's suppose that we have a graph of x squared, f of x equals x squared here. And let's suppose we have a line that cuts through that graph and intersects the graph at 1, 1, and 2, 4, like this, okay? 1, 1, and 2, 4. And let's suppose that I want to find the slope of that line. Well, we know how to find the slope. You take the difference of the y's over the difference of the x's. So let's look at that. So here we have it. So you might say, well, this is algebra 1. Well, what I'm doing is trying to make a connection. I'm going to be a little bit more abstract here in a minute, but notice that f of 2 is this 4 right here, right? So f of 2, 2 squared is 4. And f of 1 is right there. So really, if you could think about this as f of 2 minus f of 1, all over 2 minus 1. And of course, that slope is 3. Now, just as an extra here, let's go ahead and write the equation for that line. This is not, this is just something extra. We're not really evaluating the difference quotient yet. But we did find a slope here, okay? And this helps you to understand what the difference quotient gives us. So I'm going to put a 3 here. This is the point slope form of a line. I'm just going to write an equation for that line. I put a 3 here for the slope, and I pick one of these 2 points for the x naught and the y naught. I'll pick the 1, 1, and I get this. Y minus 1 equals 3 times x minus 1. And there's an equation for that line. Now, let's focus on the difference quotient here. So we've seen what we could do with, we've seen about finding slopes defined to be where a line passes through the graph in 2 points. And I gave you those 2 points. But let's suppose that I have this function f of x equals x squared, and I have it intersecting here at this point, x, and over here, x plus h. So here I'm just going to call an arbitrary value here, x, and this over here, x plus h, where this distance right here is h. So we go from x to x plus h. We go over a little ways. H is this distance right here. So we have 2 points. We have the x comma f of x, and we have x plus h comma f of x plus h, this point up here. So before I gave you the point 1, 1, and 2, 4. Now I'm saying, okay, let's be a little bit more abstract. Let's be a little bit more arbitrary. And I'm just saying, let's suppose you have some x. And then you go over a little ways further from x, and you have this x plus h. So we have 2 points here. Now I want to find the slope of these 2 points. Well, I take the change in the y's. So dig this now. I have f of x plus h minus f of x. See this? F of x plus h minus f of x. All over x plus h, see that? Minus x. Change in the y's over the change in the x's. Now notice these x's kind of get rid of each other, right? X minus x. So I'm just left with h in the bottom. Okay, now this is what we want to simplify. So I've got this function f of x equals x squared, and I want to simplify the difference quotient. Okay, so first of all, I need to figure out, well, what is f of x plus h? Well, we just put an x plus h in place of x, and we have x plus h squared. See, that's what happens when you put an x plus h in place of x. And then we have f of x, of course, is just x squared. So let's put this together. What we have then, f of x plus h, that's right here. See that? And f of x, that's right here. So this is what we have. We have the slope of this line, and we could call that the average rate of change, right? The average rate of change here. We go from here, the steepness here to the steepness here. But I'm getting a little bit ahead of myself. But we're just going to simplify this. Now, I want to multiply this out. Okay? Just x plus h times x plus h, and that's this. Okay? That's just a little bit of algebra 1 there. And if you don't recall, how we go out, multiply something like that out, you might, if I say FOIL, if I say let's FOIL this, that might ring a bell. But anyway, I multiplied that out. And now notice I have x squared plus 2xh plus h squared minus x squared. Now notice these x squareds will cancel out. And now I'm just left with this. Notice I have an h here and an h here. Let me factor that out. And that will divide out with the bottom. So the h on the bottom divides into this h up top. And I'm just left with 2x plus h. So now we can see that the slope depends on x and h. So you give me an x and an h, and I'll give you the slope of the line right here. Okay, now let's look at another example. Let's suppose we have f of x equals x squared plus 3x. So what we want to do is evaluate this difference quotient. So here I go. F of x plus h is going to be, in place of x, I put an x plus h. So x plus h squared plus 3, not x, but x plus h. And then, of course, here's the function. So we're ready to go. F of x plus h minus f of x. And here we have it. Now, you have to really watch yourself, right? Because when we put this minus, we're minusing off the whole function. We put the whole thing in parentheses, like we did here. Because if you don't, you would have minus x squared plus 3x, but it's the whole thing. It's minus the whole thing. So here's f of x plus h right here. And here is f of x. Okay? Now, we multiply things out. So I multiply this out. I FOIL this, right? And get this. Then I multiply this out. 3x plus h. See, 3x plus 3h. I just multiplied through the parentheses. And I drop the parentheses here and change all the signs inside. So I get negative x squared minus 3x. Now, when we get to this step, notice some things cancel. This x squared will get rid of that x squared. This 3x will get rid of that 3x because they have opposite signs, and we're left with this. Okay? Now I can factor out the h. Notice I've got an h here. Okay. See, factored out an h. And these h's will divide out, and I get 2x plus 3 plus h. And that's what we want it to do. Okay. Now, so this is a straightforward one. This is just, a second degree polynomial, second degree function there, and that was no problem for us. I mean, the algebra there was no problem. Now I want to look at a couple of special cases of simplifying this difference quotient. We looked at the kind where we just have like an x squared, and that just involves multiplying out, canceling some terms, and then factoring and dividing out. But what if we have something like this? What if we have f of x equals 1 over x? Okay, let's see what the trick would be to simplifying this one. Well, f of x plus h is 1 over x plus h. Of course, we have f of x is 1 over x. So the difference quotient looks like this. Now, here's the way I approach this. I multiply by the common denominator of x and x plus h, which would be x times x plus h. So I just multiply everything by x times x plus h. See, there it is there it is there, and on the bottom. So what I did was I multiplied the top and the bottom by x times x plus h, and really that's like multiplying by 1. Okay? Now, here I go. I notice that some things cancel when I do that. The x plus h cancels here, and the x cancels over here, and we look and see what's left, and here's what we have. The x is all that's left standing for this first bit. And then the x plus h, that's all that's left over there. Now, if we drop the parentheses, we see that x minus x, 0, and then the minus h right here. Now, dig this. This h and this h will divide. So I'm just left with negative 1 over x times x plus h. Now, we know we're finished simplifying this difference quotient whenever this happens. Whenever this h in the bottom gets divided out. That's what we're going for. Okay, now let's look at another one. Let's suppose we've got a square root. Now this time, f of x plus h is the square root of x plus h. And of course, f of x equals the square root of x. And here's what the difference quotient looks like. Now the trick here, the trick with the other one was we multiply by the least common denominator, the common denominator. Now the trick here is we're going to multiply by the conjugate. Now, when I say conjugate, notice the square root of x plus h minus the square root of x, its conjugate would be the square root of x plus h plus the square root of x. Notice this one's minus, this one's plus. Now the reason we do that to the top and the bottom. The reason we do that is, remember, when you multiply like a minus b times a plus b, the result is a squared minus b squared. So if we multiply the square root of a minus the square root of b times the square root of a plus the square root of b, we get a minus b. In other words, this multiplying by the conjugate is going to get rid of the radical. So what we're going to have then is the square root of x plus h squared, which is just going to be x plus h. So notice this squared minus the square root of x squared, which is just x. In other words, multiplying this by its conjugate will liberate these radicands from the radical. Okay, so now notice we have x minus x, and then the h left standing, and now these h's will divide out, and we're left with 1 over the square root of x plus h plus the square root of x. And that one's done. So notice the trick there. The trick was multiplying by the conjugate.